Right, I've decided to take a slightly different approach on the next part of what we're trying to do here, which is to enable the turtle to move forwards, backwards, up and down, because it's a lot more complicated than the left and right. And rather than spending a lot of time simply typing it out, I'm going to instead have it pre-prepared, which I've got here, and go through it with you to explain how it works. Just a couple of things I wanted to show you first is the turtle is here on the ground and can't go down. We're in the Lua prompt here. If I type in turtle.down, which won't move down because there isn't any, there is a block there, we get two responses. We get false and we get movement obstructed. I have now discovered that we can actually get hold of that error message in our own scripts, which is very handy indeed. So we can make a lot of use of that. So let's come back to here. I'm going to shut this one off because the rain is going and it's a bit of a nuisance. That's lovely. Now what we want here is, if you're doing this and kind of in a follow along session, you want to make 4 separate functions. So you've got check args, do moves, and inside the brackets there we've got num blocks requested, do dig and direction. This will all become clear when we start to go through the code. Then another function called print log with the number of blocks requested, the number of blocks moved and error message. And then of course main, and then we do our main call here, and at the top args equals the open curly brackets with 3 dots. So we're going to assume in this case that our user is typing in F for forward, 5 and dig, so that he's asking us to move 5 blocks forward and to dig if necessary. So args1 will be made in will receive the word 5, the number 5, and args2 will receive the string or letters dig. So this is how it's going to work. Now if I go first of all to the main function, what I've put here is I've highlighted this with comments to make sure that you follow this. We're going to set up a local direction here equals F. So if you are writing the forward or f.lua, then put the letter F in here. If you're going to write this for the back, you would put a B in there. If you're going to write this for the up, you put a U in there, and so on. So this means that we can use exactly the same program for all the different movements. So this is quite a comprehensive program. It's also much more complicated than the one we did before, but I'll try and take it as slowly as I can. So this is a local variable called direction, and it holds the string, in this case F. This is for F Lua. Then we've got a local variable set up here, the number of blocks requested, and do dig, and then we're going to get those little pieces of information from a function called check args. So if we now open check args, it's not too difficult. What we've got here is we've got 2 local variables, the number of blocks requested, which we've set to 1, and do dig, which we've set to false. So that if we typed in just F and hit the enter key, it would check the arguments and find that we're going to move forward 1 block, and then we're not going to dig because those are the defaults. So these 2 are setting the default conditions. Now if we look at args1 and it's not equal to nil, in other words the user has put in a number here, or at least we hope they put a number. Of course if they put something else then it's going to crash out, but that serves them right for being stupid. This time we're not going to be checking whether they've typed in a number. That makes it a lot more complicated. So if args1 is not equal to nil, then that means it's a number, so we can make the number of blocks requested equal to that number. So in this case it'll be 5. Then the second thing we're going to check is if args2 doesn't equal nil, then do dig equals true. So it doesn't really matter what you type in here I didn't have to type in dig. I could have typed in X or GH. It really doesn't matter. The only time it would matter is, no, even then it wouldn't. I was going to say the only time it would matter is if we added yet another argument, but that would be args3 or 4, and we're not even checking for that. So you can type what you like here. So args2 is if you've got anything at all in here, it'll set do dig to true, otherwise it'll be left as its default. So this whole function just checks what's inside the arguments and gives a definitive value to the number of blocks requested and whether or not we're going to do a dig, and it returns it back to what was calling it, which is down here. So check args. We'll now get two values in it. It'll get, first of all, whether or not we do a dig, which will be true or false, and the number of blocks requested, and in this case, because we passed in a 5, it's going to have 5. So 5 blocks, and again we put some nonsense in here, so we're going to be doing some digging. Now, next job it does is to check the fuel level of the turtle. If it's 0, then it'll just print out no fuel. Else, if you've got some, well, we might as well tell the user how much they've got. So fuel level, turtle get fuel level. If, say, they wanted to move 10 blocks and you've only got 6 fuel level, it obviously wouldn't make it because it wouldn't have enough fuel, but it would then only move the amount it could do and tell them how many it's moved. I suppose we could make this even better and tell them that there's not enough fuel, but I'll leave that for you guys to do as a sort of a refinement to this. So the fuel level is 0, it prints no fuel, and that's the end of the program. It comes out of the main function, it's finished. Else, if there is some fuel there, it'll say fuel level, and then it'll add the fuel level to it by using the string concatenation, double dots here, so we get fuel level and what it actually is. Now we're going to set up 2 more variables here, again local. This is a new one called numBlocks moved and error message. So these are now being created locally in the main function, and we get them from a new function called doMoves, which is up here. And doMoves is going to be sent 3 pieces of information: the number of blocks requested, which in our case is 5, whether or not we're going to do the dig, which in our case is true, and the direction that we want to dig in, which in this case has been hard coded to F. So that's why I've underlined and done all this here. If this is now going to be your B.lure because of going back, or your U.lure for going up, or your D.lure for going down, all you need to change in each of those programs is 1 letter, and the whole thing will run perfectly for the rest of it. So it's very important that you change that. So this is, we're now going to move forward. So we're now going to call the doMoves function up here and do the moves. This is perhaps the more complex of all of them, so let me shrink out of the way these 2, and we'll open up doMoves, and we'll slide that down to try and get as much of it on as we can. So we're passing into the function the number of blocks that we want to move, whether or not we're going to dig, and the direction we want to move in. We've got 3 local variables that are set and initialized up here: the error message, which has been set to nil, the number of blocks moved is set to 0, and we've not defined, we've just given them names: move, dig and detect, but we haven't kind of set them to any values. We've just kind of created a bit of memory space for them to be used, and you'll notice this time I've used capital letters, which is slightly unusual. Most Lua variables start with a lowercase by convention. So now this is where the clever bit comes in. Let's check this one. It says if the direction equals F or the direction equals B, which of course this is because we've chosen the forward direction, then what we're doing here, and this is a really clever piece of coding, is that we're creating a new function called move, which borrows the turtle.forward function. You do not put the brackets on in this case, because what would happen then is that would actually call and make the forward function work, which of course we don't want at this case. So what we're doing is we're reassigning turtle.forward into a new variable called move. The same with the dig function. We're reassigning turtle.dig, again without its brackets there, and the same with the detect one. So we've now got three brand new functions: move, dig and detect, and they're equal if we're moving forwards to turtle.forward, turtle.dig and turtle.detect. However, if the direction we were traveling wasn't forward but it was up, then we're reassigning those exact same three functions to the equivalent of turtle.forward, which is turtle.up, dig up and detect up, again without the brackets. So you can see what we've done here is we're using a pre-made function and assigning it to a variable. That's why I've used the capital letters here, to kind of remind us that we're now calling a function rather than a simple variable. One last one I've put in is if the direction equals B, which is of course meaning we want to go backward. I really want to use all the stuff that turtle.forward, dig and detect uses, but we want to reverse the direction of the turtle first and then carry out those functions. So if we're going backwards, turn the turtle right twice, which would of course reverse its direction, and then it carries on in the same way as turtle.forward. So that's that one. I'll just come up, scroll here. So I hope we understand all that. It's quite complex, quite clever, but it works really well. Now again, we've got a for loop, and we're going to run it for as many times as the number of blocks requested. The comma one here just means do it sort of one step at a time. We don't actually need that at this case, so we can just leave that as it is. For a equals 1, number of blocks requested do, so this is our for loop, and the number of blocks requested in our case was 5. And then we're going to call one of our brand new functions here. So we're set up to some local variables. We want to know whether or not, let's say this move here is now the equivalent of turtle.forward, because it is. We've chosen F, so we're now doing turtle.forward. So we call turtle.forward, and it will reply with a true or a false whether it moved or not. And if it didn't move because there's a block in front, it'll give the error message movement obstructed. So that will be stored in here. So we've got now the success of whether or not our turtle moved, and if it didn't move, the reason why it didn't move is stored here. So that's very useful. So the reason we did this, of course, is that we can now use the exact same program with only one change of one letter to make it check whether it's going forwards, upwards or downwards. So that's the clever bit. Right, so we run the forward turtle.forward function here, and we get whether it moves or it doesn't move. So we're then going to check whether or not we're going to do a dig. In other words, if there's a block in the way, do we do it? I'll come back to that in a second. First of all, we're going to check down here, which is where we're not going to do a dig. So we're only going to go forward if there's nothing in the way. So this checks if move OK. Now, of course, move OK was run up here to see whether or not turtle.forward succeeded. So if that is OK, then it succeeded. It's moved forward. So we can then say num blocks moved equals the number of blocks moved plus 1. So if it was 0, we add 1, and we've now got 1 block moved. Now, if move OK was false here, in other words, it didn't move because turtle.forward failed, that usually means there's a block in the way, and the error message would come back. And the error message would be whatever the error here was. So it might be obstructed, path obstructed. So we've got that error message has now been given a value. So that's if we're only moving without digging. So it'll move, and then of course that will then run for the number of times that number of blocks is requested. So if it was 5 and there was nothing in the way, every time it ran through it would do this, and hopefully error message would stay empty because there was nothing in the way. Now if on the other hand our move OK, well, we're now going to do it if we're also going to dig. So the move OK will either be, in this case, true or false. If we imagine that we've got a block in front of the turtle, the first time it runs, move OK would be false, because the move forward, or turtle.forward, is not working because there's a block in the way. So if we've given permission to do a dig, which we have here, and in our, when we set the arguments up here, we're now going to do a dig. So we then check whether we can do our dig. So if the move OK was successful, in other words the turtle moved, and we're able to dig, then all we do is just increase the number of moves that we've made. Job done. We don't need to worry about it. So we're able to dig, but we don't need to in this case because there was nothing in the way. It just increased the number. But if it didn't, if move OK wasn't alright, in other words there was something in the way, we can then try and dig it out. So we'll use this while not. So move OK, as we know, is false because it didn't succeed in moving forward. So while that move OK is false, which is where I've used while not move OK, if you prefer, it'll work exactly the same while, if I put it this way, equals false. If you find that easy to understand, that's quite all right. So move OK is false. We're now going to use a new one of our second functions, which is the modified dig function. And again, we're going to get two values from it. So I've called them dig OK, which is going to be true if it did dig a block, and false if it didn't. And dig error is if it couldn't dig it because it was the unbreakable block, the bedrock. If it was bedrock, dig error will give you a message saying unbreakable block. Again, dig is now turtle.dig because we've set it to that. So we're going to try turtle.dig and see if it works. Now if it does dig the block, so it was just a stone block in front, then that's okay. The OK will be true. Now what happens if I just drop that out of the way and back to the game? If we get some sand, just look for that, or gravel even, and we put sand in front. So if our turtle digs that block of sand, then the one above it is going to drop in its place. So we need to make an allowance for that. I just had to pause there to clear the weather. So sorry, as I was saying, if you've got sand in the way, it'll dig the lower block, and the blocks above it will come crashing down. So they also need to be dealt with. By adding this sleep for half a second, that just allows a little bit of time for the sand to drop, and then you can then repeat the dig section and repeatedly until all the sand has gone. So if dig OK means that it succeeded in digging, so we just sleep for half a second and then carry on, and then we try the same thing again. We try to do another move. So we're resetting the variables move OK and move error. Again, if it's alright, it does its job and it moves, then the number of blocks moved is increased. And so that keeps a tally of how many movements we've made forwards. Now if on the other hand when we tried we were unable to move, and we tried to dig and it was false, then the most likely error is that there's an unbreakable block detected. Then that's what the error message becomes. The only other time I found where a turtle won't move is, I believe, in a minecart. A minecart for some reason won't break. Bizarre behaviour, unless they have fixed it since the version I was using a few years ago. But so otherwise we're going to get this error message coming through. So that's how this whole thing works here. Now, once we've done that and we've moved the number of blocks that we wanted to move, digging them if necessary, if we were going backwards, we want to turn the turtle back round again, and then we're going to return the number of blocks moved and any error message back to the main function. So we'll just drop that out of the way. So we've now started to do our moves, and we've got two things back, the number of blocks that we've moved and any error messages. And then this new function print log is going to be given the number of blocks requested, the number of blocks moved, and any error messages. So again, we've got this new function. Let me open that one up, close that one down. This is relatively simple. So it's going to print moved forwards the number of blocks moved out of the number of blocks requested. So if we requested 5 and it moved 3 because of some error, it'll tell you that it's moved 3 out of 5. It may be, of course, it ran out of fuel. So that's pretty much how this one works now. And in order to make this into the b.lure and a u.lure and a down.lure, all you need to change is in the function main is to change this letter to either u or d. So I'll be back with something else on the next video.